In this video, I'll show you how to import the data from your electrochemistry lab report into Excel and do the statistics that you need to calculate your X and Y error and then how to create an X and Y error bar plot in Origin. So first, with Excel open, File open, and look for your data file. Hopefully you've named it something that you can remember. Usually though, Excel opens up with this, looks for Excel files, and it will not see the data that you're looking for. So you need to go through here and from the pull-down menu, go to All Files, and now you can open up your DTA file from the Electrochemistry workstation. This will open up the import wizard of Excel, and the data is delimited. You get a preview of the data here, and there's a lot of header information that could come in useful as you try to analyze your data. The delimiter is going to be tab in this case. If you scroll down, you can see that after all this header information, the data starts, and because we selected tab, it's going to start in these, it's already set up in the columns. So here's our data. If you expand this column here, you can see the date and time when the data was collected. These are the settings on the potentiometer. And we scroll down, and here's the data we're interested in. This is the voltage, and this is the current. At each time interval, we had set the time interval 30 seconds. So every data point is every 30 seconds until the completion of the experiment. So what we want to do is to calculate how much did the voltage change during our 900 seconds that we measured it. And let's say we want an average or mean. So we can do, in Excel, this is called average. And we highlight the columns that we want to average. And then to find the standard error, Excel has the calculation of standard deviation. It doesn't have the calculation of standard error. So again, we can highlight all of our data points. And now we're going to divide that by the square root of the number of data points. So we can find our number of data points. We can either manually count them or we can have Excel count them. And we're going to take the square root of that. Okay, so that's our mean and our standard error for our first data set. And we'll put that into Origin to begin our data file. So in the X column here is going to be the temperature. And we should put it in Kelvin because this is a thermodynamic measurement. And then here we're going to put the voltage, or the EMF, electromotive force, in volts. And our first, we got the voltage for our first temperature run, and we have the error, so we need to add error bar here. So up here we can go to column, and we can add a new column, and it will add it to the right at the end of the worksheet. And actually we want to add two columns because we need an error column for Y and an error column for X. And now what we can do is we can move the columns. Let's move to the left, and that will become our X error bar. So if we right click on this column, we can change the type of column it is. And instead of calling it Y, we'll call it X error. And then we're going to do the same to this column. We want to change this to the Y error. Now, before we get too far along, let's save our project. Okay, so far we have EMF versus T for, well, we only have the EMF part here. 3.02 volts and 0.001 is the standard error on that. Okay. What is the temperature for this 3.02 volts? Well, if we saved our data file with the temperature name, that could help us. Otherwise, we can look up here and we have the day and time when the file was made. And so we can compare that with the day and time for our temperature data. Let's open our temperature data. And our temperature data is not necessarily going to be recognized by Excel. There's no file type indicated here, so we need this all files selected in order to see it. If we double click on that, say go ahead, yeah, we know where this data came from, and it'll open the import wizard again, and again we get a preview of the content of the file. It is delimited, and if we say delimited by tab, we see that we have date and time in this column, temperature, units, and so on. So this will work for us. And let's expand this column so we can see it better. And this has the date and time that corresponds with our electrochemistry data. So this must be the temperature data that we want. And what we can do is the same calculation. Actually, let's go ahead and copy that so I don't have to keep typing out the calculation here, since Excel doesn't have a standard error calculation. So we want to take the average of this column, which is our temperature in Celsius, except we want to convert to Kelvin, and temperature 2, we didn't have a second thermocouple, so this data doesn't matter here. We can just clear that out of there. So let's go up to the top and make a new column that's going to be the Kelvin. So if we highlight that, we can copy it all the way down for all these data points. If we look down here, we see at the end of the data run, we took the thermocouple out of the water bath, so we don't actually want this data in our final calculation. So let's save our work so far just to make sure we don't lose it. And let's make it an Excel file because we're doing all these calculations to it. Okay, so now we want to do a mean and standard error for Kelvin here. So let's make sure it's looking at the right range. Nope. So we want to change the data range here to this data here. Okay. And then same for the standard error. We want to change the data range to the actual data values that we want. And do the same here. And so now we have the temperature in Kelvin and the standard error. So that's what we want to put into our origin file as our T column here. Temperature was 302 kelvins, or 303, the standard error is 0.04. We should probably show more sig figs there, but we should have significant figure in the tenths decimal place. So we do want to see more the number here. So we can increase our decimals. 302.9 is what it would be. Okay, so we have our temperature and our voltage and the errors for those. So we continue doing that for our other temperature runs.